Hi, and welcome to my demo of how to use SPSS to conduct a single sample t-test. So up on my screen, I have an example scenario. It says, are elderly people's attitudes less favorable towards technology than the general population? A social psychologist assessed the attitudes of 11 elderly people using a scale where a lower score indicates a less positive attitude overall. The mean on the scale for the general population is 23.1, but the standard deviation is unknown. The data for the elderly participants are shown in the table. So what I did is I actually went ahead and put the data into SPSS. So what we have here is we have data from a small group of people, 11 elderly people. We have their attitudes, and we want to compare it against a known population of 23.1, but they don't know the standard deviation. So since we know the population mean but not standard deviation, we would need to conduct a single sample t-test. To do that, you're going to have to enter your data from your sample into SPSS and remember that mean that you're going to compare it against. So we need to remember this 23.1. Okay, so to enter your data into SPSS, you just open up SPSS and you'll be in data view, and that's where you type in your numbers. So you'll see here we have a 21, a 23, 20, 18, 17, 20, 24, 21, 19, 17, and 20. So you enter your numerical values in your data view just in one column. I had 11 people, so I have 11 rows. If you had more people, you would have more rows. Once you enter your data, you can go to variable view, and this is where I'm going to name my variable attitude. And I could change my scale of measurement to be scale. And so it doesn't matter which one you do first, actually. You can do data view or variable view first, but I like to have both of those set up. And now that we have all of your data entered, we can conduct our single sample t-test in SPSS. We're going to go to Analyze, Compare Means and Proportions, and go to Single Sample T-Test. And so it's going to pull up this box. It says one sample t-test on top. We want to put our variable over into the test variable. So you just have it highlighted. You click the arrow, it moves over. Now we need to change this test value. Test value of 0 would just say, do those attitudes differ from 0? But we want to know if they differ from the general attitude of the general population, which is 23.1. So you just type in the 23.1, make sure your estimate effect sizes is selected, and then click OK. So here is our output. What happens up here is it shows the total number of people we entered data for, so you can double check yourself, make sure you entered everybody, the mean and the standard deviation and standard error of the mean. So the mean is 20. We are seeing if that's statistically different from 23.1. So here's our one sample test. It shows us our test value, and then we see our T obtained, the degrees of freedom, and then the significance column. We wanted to know if they differed from the general population, would make it two-tailed because we don't know if they would be higher or lower. We just want to know if they differ. So we're going to report the two-tailed test. And then we will also need to look at our one sample effect sizes. We will look at our point estimate for Cohen's d and see it's a 1.39 if we're going to round. Okay, so the only thing before we can do a write-up is the confidence intervals. The confidence intervals are now in the different scores, and usually people want you to report the confidence interval in the actual original data, so the attitude scores. So to get the confidence interval back into attitude scores, we're going to go to Analyze and Descriptives and go to Explore. And then we're going to put in our little box here, we see attitudes. We're going to put that in our dependent list and statistics, and make sure descriptives 95 is selected. Click continue. We just need statistics, so I'm going to click OK. And now we'll be able to report our confidence interval using actual attitude scores. Okay, so that shows us how to get all of the data. And so you can stop now if you were just wanting to know how to write or get that in SPSS, but I'm going to go ahead and show you how to write it up. So I'm going to just pull this up to the side so you can see where I'm pulling my numbers from. I'll make it a little smaller. Okay. So when you're writing up results, you would need to say first what you did. So we could say, a single sample T test was conducted to examine whether elderly attitudes towards technology differs from the general population. Mean equals 23.1. It was statistically significant. And then we can write let me see why it keeps doing that. We can actually write up our statistical notation now. So you'd write a T, it'd be italicized. So I'll have to come back and italicize it. And then in parentheses goes your degrees of freedom, which is right over here, that 10. And then you're going to pull up your T obtained, which I usually round to two decimal places. So it's a negative 4.60. And then the p-value, which we're doing two-sided, but it still equals less than 0.001. And then also we need to report our effect size, which is that point estimate of Cohen's d's. So I also round that one to two decimals. So it'd be negative 1.39. Doesn't matter about the positive or negative, but you can put it in there if you want. And then the 95% confidence interval of, and we'll have to go down to here to get it. And it was 18.50. 18.50. We usually start with the smallest and go to the largest, 21.50. Okay, so that's where I got my numbers from. This is my current write-up. I'm going to make it bigger so you guys can see it. It says a single sample t-test was conducted to examine whether elderly attitudes towards technology differs from the general population. Here it would be more important to actually put the symbol for the population mean. So there we go. It was statistically significant. All your statistical symbols need to be italicized. So we're going to do the T, obtain, the P, and the degrees of freedom. All right, so we have all of our data. Now we need to explain how it was statistically significant. You could say um, elderly had less favorable attitudes towards technology than the general population. And there we go. So we're saying what tests we conducted. We're letting them know everything you would need to be able to check whether that statistically matches out. And then you actually provide your statistical notation, which is how you know whether your hypothesis is supported or failed to be supported. And then if it is statistically significant, you have to say how. So we found out that 20 is less than 23.1, so they had less favorable attitudes. All right. Thank you for joining.